Hello, welcome back to Matt Tomorrow's Physics, and today we're going to be continuing forces which we started in the last video. So let's just jump right into this video. So let's imagine that we have a book and it is on this table, right? And let's say this book weighs 2. We're not going to give it a unit right now, right? And so what's pushing down this table? Well, that's going to be the force of gravity coming down. And then what's going to be the force pushing it back up? Well, that's going to be normal force, which we did discuss in the last video, but I'm going to reintroduce us to this. We can call this N for normal force. And this normal force is based on Newton's laws of motion, where paraphrase, this is my paraphrase version, that everything has an equal and opposite reaction to itself and to something else. And so if you're, let's say, pushing against a wall, right? You're pushing against this wall, right? That's a person, and so this, you're exerting some force to this wall, but it's exerting back the same force back at you, and that's why the wall does not move. All right, and so we're finding the same thing here, right? And but since the book is staying on the table, the normal force is pushing the book back up because it's fighting that gravity which is coming down. So we can start by writing our force equation for the force of the gravity, right? And that's going to be F equals ma, right? So the force is going to be equal to the mass, which is 2, times acceleration, which is gravity in this case. So we're just going to call it g. So the force coming downwards is 2g. Now, if you want to find the net force, right, we're going to write it in the form upward force, which we can call U sub F, minus downward force equals 0 in this case, because the book is not moving, right? Like nothing's moving right now. So the net force is going to be 0 because, you know, there's no motion. And so you can kind of get this formula from if you take the F here and then you subtract 2g equals 0, and then that initial force is going to be our N, right? So it's going to be N minus 2g equals 0. So there's a few ways you can think about this, right? So let's think about this in like a coordinate plane system. So if something is moving up in the y-axis, positive, or right in the x-axis, is going to be positive, which means that you're adding that force. And if it's moving down the y-axis or left in the x-axis, is going to be negative. So since the N here is pushing up, it's an upward force. That's why it's going to be positive N. And then you're kind of adding, but it's really not, right? You're adding a minus 2g, right? Because and that's kind of what's coming from this formula. Minus 2g because the 2g is pushing down, so it's going to be equals 0 because nothing's moving. So N minus 2g equals 0. And that's how you can represent this in a net force equation. And yeah, that's all for this video. Thank you. Hope you learned something.